Alright, we're going to start a recording here. This is a virtual machine, so Control F will take it into full screen. I'm going to start by making an object. Make the simplest object I can. Go into the geometry, hit new, cube. I'll just keep it like that. First we'll do a 3D. I'll have an inlet pipe, so I'm just doing this in general. I don't want it to be right there, but I'm fine with it being right there. I'll do another inlet pipe. However, why don't I just take this cylinder and copy it? So I'm doing a create a copy. I'm going to move it to, say, the other end and have it push things out that way. So here. Okay, turn back on that original cylinder. So now control right mouse button and you can see, let's have fluid coming in one side and going out the other. So we need to fuse this all together. So what I'll do is select all the objects. I'll hit the fuse. It says 3 objects are selected. It's calling it fuse. What we'll do is call it complete. You can call it anything you want. After it does there, it turns off the others, and now what you see is the complete item here. Before I continue, I need to explode it, have the faces available, and there are my faces. I have 10 of them. What I'll do is go through here one at a time, taking a look at which ones are. Hit the F2, type in wall, go down. I'll go ahead and turn that one off. Let's turn it on and off. Let's have that be the exit. Turn it off, go down one. I'm not sure what I'm turning off and on. Turning off the bottom part. That looks like a wall. Now this time I'm not going to do a symmetry, just to have everything there. Turn it off. Okay, turn it off. Face 5 is a wall. F2, wall. Turn it off. Oop, I had it off. 6 looks like a wall. F2, type in wall. 7 looks like a wall. F2, wall. 8 looks like a wall. F2, wall. Now I don't know what this one's still doing there. It is face 3, which I did not pay attention to. F3, wall. So you can see from this, F2, wall. You can see from this, you can select them and it'll go to the item. Okay, so I'll have that one be the inlet. And apparently this one will be a wall as well. Oops. F2, wall. Oops, wait. That was the inlet, F2, inlet. I have everything identified. Take the complete, go into the grid module. Go ahead and create a mesh. Do a 3-dimensional mesh off of the NetGen. Do the parameters and we'll do very fine. Apply and close and we'll generate it. So there it is. Because I'm running this on a little bit faster server, I'm going to go ahead and go back to the parameters, edit, and this time instead of 9, I'm going to drop it down to 4 and say 12. What you notice is exclamation point shows up there. Hit generate again. It may take a few minutes. They may take more than a few minutes. That's okay. Okay, sometimes generates quite a fine mesh there. Maybe more than what I need for this example. So I'm good. Now what I'll do, go into mesh, create groups from the geometry. So come back to here where the geometry is defined. This is the geometry module. We'll say apply and close. You've got them all. Now here, I'll drag this over a little bit, and you can see I can cut the solid off and cut on each of the walls. I mean each of the surfaces, and kind of inspect them if I felt so inclined. If I don't feel so inclined, I'll just, well, first I'm going to save this. I'm going to save it as, I'm going to put it on the desktop. I'm going to create a directory, call it Study01. Go in there, and that's the Salome file. That includes everything here, the geometry, the mesh, and everything. Select the mesh, right click, export as a UNV file. We'll just keep it as that, save, and we're okay. I can drop this out or I can leave it there. I might need to reference it in a little bit. I will go in, Open Foam Wizard, study name. I don't know what to call it, EIEIO, base directory. Go into the desktop, study. We'll say that's good enough. I'll go in here. This is just my way of doing it. It doesn't have to be done in this particular way. There's the mesh. Inlet groups. Now here's where I might need to have both of them up here to make sure that I'm using the right words here. I can use anything I want here. Inlet, outlet groups, exit, wall groups, wall. I have no symmetry group. Now the inlet velocity, if I come down here, I'm in the inlet here, taking a look at the inlet, turn this thing all the way around, try to orient it. So here in fact is the inlet. Let me turn it off and back on. So the key is you want it to be coming in, flying into here. This is the positive Z, so it should have positive Z velocity coming straight into here. So it should have 0, tab, 1, 0.0375, and then 0.0. Now, let me see if I can remember this. I'm just going and copying what is in the documentation for the time being. I'm not claiming this is exactly what should be done all the time. Go to high Reynolds number, let it kind of get itself oriented, and I'll go down a page. So I'm looking to get these values right here. Again, this is if you specify the kinetic energy, you have to have a certain dissipation that obeys approximately this equation. So that's what I'm going to use. And here, I'm going to just pick 0.01, go, give it a minute. Has it been created? Please check the generated files and then type run SimpleFoam to start the solver. Okay, let's do that. Go to CAE Linux, go to the terminal so everything is set, change the directory to the desktop. I can hit the tab and it'll fill it out. I can do a CD and hit tab and it'll tell me all the things that are available in that directory. But type in the capital S and hit the tab and it fills that out. LS is a listing, DIR is a listing. So I put the study in EIO list or directory. You could do ls-la and it'll list everything. So what I have is a shell script right here. So you type /simple, and now you can just hit the tab and it will fill out that. I'll make the screen a little bit larger. Hit enter. May take a few minutes here because there's a lot of elements. So I may pause this, come back to it, and again maybe I won't. Here I'll hit the Control F, go to my recording. You can still see it's recording here. I'm going to pause the recording. We'll come back in a second. Okay, we're back. Looking at the virtual machine, Control F takes it to full screen, so we're back where we were. You can do a directory and look and see what gets added, or ls-la, list everything. You got a 0 all the way to 100. These are the time steps that it wrote a solution. If we want to see it, I type in ParaFoam. It will load everything in there. Hit apply. You'll see your geometry. This should be the inlet over here. I want to see velocity vectors, so I'll apply like that. What you're seeing is very faint velocity vectors at the inlet. If you want to see more, select this surface, go to display, and maybe what you want to do is make it a little bit more opaque. Hit properties. Okay, so now it's a little bit more opaque. When you move it around, it renders a little bit slow, mostly because it's a virtual machine. Now, we're at the initial time step. If we want to run ourselves all the way through it, you'll see simulation goes to about right here. Now, I can't guarantee anything's converged, and I can't guarantee anything's accurate, but there is a solution. And you can see the flow comes in here and disperses inside this chamber and ends up going out. If you want to see some stream traces, you see I click that, you see stream tracer, and you see a plus sign right there. I can hit apply, and what you'll see here, let me turn off this, and what you'll see, flow particles swirling around. Let's see if I can move it maybe over more down in this direction. hit apply, you'll see the particles streaming around in that direction. So let's see. Okay, I'm trying to see the view. Let's see. I used to remember how to turn it in from perspective to orthographic, but it's been a long time. Sometimes you can search around and find it. Not finding it right now. But in any case, as I move the cursor, it turns to a finger. When it turns to a finger, I can move the object again. And if I rotate through here, hit the apply, you might see that I can bring it down into the tube, the inlet tube. When you see that, I think here I can change the radius, bring it down to say 10, see a tighter cluster of points. I can look at the display. I want to color it by the velocity, for example. Don't really see much there. Color it by the pressure, maybe. Don't see much there. Stream tracer, too opaque. Ah, there we go. Now you can see them a lot better. See them coming into the flow. Change the pressure to say vorticity, see what you get. So go back to the properties. Minimum stick length, initial, maximum. Here, let's put a 0 right there. Hit apply. Let's see, 20,000 steps. So you can see that basically comes in, hits the top of the roof. There are other things you can do as well. Let's take a look at other things. We can take a slice. Select that, take a slice of it, hit applied. You might not want to show the plane. Then you might want to go in here to display, go back down, see if you can find the opaque and get rid of the opaque nature there. Then if you rotate it around, you'll see that plane. You might be interested in the pressure on that plane, say. Instead of a solid color, put the pressure in there. Or you might be interested in the velocity. This is the point values, the other is the cell values. You might be interested in looking at a velocity vector only, field only in that plane. Now, if the vectors are too small, you can, or if there's not enough of them, you can add as many as you want, or you might make them a little bigger, say 50, or maybe 80. Now what they are is they're velocity vectors in that plane. So you can see you have selected a plane and wanted to know the velocity vectors in that plane. Some of them come out of the plane. Some of them, if I can line this up better, let's see if I can. You can see some of them coming into the plane, some of them coming from, in this case, going from right to left, some of them going from left to right. So there's a lot of things that can be done with this. I'll say this video is done. Here, let's do a couple other things. Okay, display of that plane. Let's turn off the velocity vectors. And then let's say I want to know in that plane, I'll pick, say, the pressures. I don't get anything very exciting, but I might be interested in the resolution in that plane. Here, let's see. What I mean is that there are all the triangles in that plane. You might be interested in all the points. You might be interested in a wireframe or surface with the edges, which looks kind of like you might 3D. That's not going to get you anything. But a surface is the most common default. I'll draw this one to a close.